Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 61 in our incredible new tutorial series where you're learning how to think like an engineer using the Arduino Uno R4 Wi-Fi. What I will need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee poured over ice, no sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at Sunfounder. Sunfounder is actually sponsoring this most excellent series of video lessons. And in this class, we will be using the Elite Explorer Kit. Now, hopefully most of you guys already have your gear, but if you don't, take a look down in the description. There is a link over to Amazon, and you can hop on over there and pick your kit up. And believe me, your life and my life are going to be a whole lot easier if we are working on identical hardware. But enough of this shameless self-promotion. Let's jump in and talk about what I am going to teach you today. And what we're going to do is we are going to build a portable weather station that can measure barometric pressure, temperature, and humidity. The results will be displayed on a small OLED screen, and besides having one little page that will show you the real-time values of temperature, pressure, and humidity, there's also a push button, and if you press that button, you will be taken to a new page that shows the barometric pressure over the last 24 hours in a graph, and at the top of the graph, the present live barometric pressure reading. Press again, you'll get the graph of temperature with the present temperature at the top. Press again, you will get a graph of humidity for the last 24 hours with the real-time humidity up front. Sound good? I hope it does, because it was actually the homework assignment from lesson number 60. So I should ask, how many of you guys were successful? If you were successful, leave a comment down below. I am legend. If you were not successful, leave a comment down below. I folded up like a cheap Walmart lawn chair. But never fear, because I'll show you my solution today. Now, most of you guys probably are following along in this class. If you guys are just jumping in, you drive-by shooters that just landed on this particular lesson. We've done 2 or 3 lessons before this building up to this. You can just watch this lesson, but if you start getting lost, you could go back and catch a couple of those earlier lessons. Does that sound good? I hope it does. Okay, so let me show you sort of what we're going to be doing today, and this is what our end result is. You can see we have the Arduino, we have a push button, we have the BMP 180 sitting on a GY87. Is it a GY or a GX87? I can't remember. Maybe it's a GX87 module, and it's the BMP 180 pressure sensor on it. We have the DHT11. We have the DHT11 temperature and humidity sensor. We have the SSD1306 OLED display, and then we've got this power module here to power the whole thing. Now, this is where we come in. On our home screen, when we run this thing, we have a live reading of our present temperature in degrees F. We have a live reading of the relative humidity, and then we have a live reading of the barometric pressure in inches of Hg. If I come in and press this thing, it takes me to a 24-hour graph of the barometric pressure with the real-time reading. If I come in and press it again, I will go to a 24-hour graph of the temperature in Fahrenheit. I press again, and I can see the live relative humidity, as well as a graph of the relative humidity over the last 24 hours. So that's what we're working towards. But to get there, you are going to need a couple of things. We're going to go get that code that we developed last week, and then we're going to take that code that we developed last week and then build it out to do all the things that I showed you here today. So you will need to open up a fresh new Arduino IDE, and then you are going to need to go to the most excellent excellent, www.toptechboy.com. When you do, you'll need to come up to this happy little search icon, and search on portable Arduino barometric pressure weather station, and you will come here. You can see here's the circuit schematic of where we were last week. You notice this one doesn't have the DHT11 in it. Well, we're adding the DHT11, but otherwise the circuit stays the same. We're going to come here and we're going to snag this code, okay? So we copied the code. Now we're going to come over to Arduino and we're going to paste it. Now you guys are exactly where we left off in last week's lesson, but now you're also going to need to know how to hook up the DHT11. Now, if you guys have been following along, you can see the DHT11, you just plug it in. The left leg goes to the power rail. The second leg, pin 2, goes over to the digital pin 11 on the Arduino. You skip the third pin, and then the rightmost pin goes to ground. So that's pretty easy. And if you have most of this already built, you can just plug in your DHT11. But if you're starting from scratch, you'll probably want to go to the website and look at this and build this thing pretty carefully. Okay, now, last week, what the program did was it would just measure barometric pressure, and then every 10 minutes it would update the graph, okay? And it all went out to the OLED. Well, now what we want is we want one screen where we have the 3 live readings of barometric pressure, temperature, and humidity. And then if you press the button, you go to the graph of the pressure. You press again, you go to the graph of the temperature. You press again, you go to the graph of the humidity. You press again, you go back to the home page. So what we're going to have to do is, this is not a whole lot of new stuff, but we've just got to add stuff to what we're already doing. Also, I should say a little bit about how we're going to do the program flow, or the kind of flow management. And we're going to have that button, and we're going to need to, first of all, be able to detect if the button's been pressed. And then if the button has been pressed, what we want to do is we want to increment the button count. And then what I do is I just take the button count and I mod it, which is the percentage sign. I mod it with 4, and that gives me the number divided by 4. It gives me the remainder. Okay, it is the remainder. And so what that means is if I press, and I mod that number of counts by 4, at first the remainder will be 0, and then 1, and then 2, and then 3, and then back to 0. So using that mod function allows us to just create a sequence of 0, 1, 2, 3, 0, 1, 2, 3 as we continue to press the button. Okay, so that sounds pretty good. But if we're going to do that, we're going to have to go in and we are going to have to add. We're going to have to go in and we are going to have to add some variables. To start with, what we've done in last week's lessons, we've loaded in the libraries that allow us to operate the OLED screen. That is, we're going to need to have SPIH, WireH, and then you're going to need to install the Adafruit GFX library, and you're going to have to install the Adafruit SSD1306 library, and you're going to have to install the Adafruit BMP085 libraries, which we did last week. But now this week, what we are going to do is we're going to get that DHT11 going. So we're going to need to include we're going to have to include DHT11.h like that, and you'll need to install that. That doesn't come with it. So we come here, you search on Adafruit DHT, and then it is this DHT sensor library by Adafruit, and you can see I have the most excellent version 1.4.6 already installed. Okay, but you'll need to install that if you haven't already. Now we've got our libraries taken care of. Now what we are going to need to do is we're going to have to define a few constants. So I'm going to define, and the DHT pin. What did we say that was on the schematic? It is pin 11. We have the DHT 11 hooked to pin 11. All right. And so we're going to define that. And now I'm also going to define, and then the DHT TYPE, the DHT type. And we are using a DHT11. If you have one of the more higher end sensors, you would need to put in that name. But we are using from the kit the DHT11. Now what we're going to do is we're going to go ahead and set up our humidity sensor object. So it's going to be DHT, the library that we just brought in, DHT, what we are naming our object. And then what does it need to know? The DHT pin that we just defined and the DHT type that we just put in. Okay, now that will need a semicolon. This one, my friend, does not need a semicolon, and that one doesn't. It's that unusual thing that includes and defines don't need the semicolon, and almost everything else does. Now let's go in and see if we can manage that button. And so if we have a button, we are going to need a butt pin, and we said that that was pin 2, if you remember, butt pin 2. Okay, then butt val, and that was going to be equal to 0, all right? And then the butt val is what is the value of the button. Now, when you start and you're just sitting there, we're implementing the button with a pull-up resistor. So while it's sitting there undisturbed, it will be reading a 0. So we'll go ahead and we'll initialize it to 0. And then remember, we need to know what the button position was the last time through the loop. And so we also need butt val old. And since the program has just started, no buttons have been pressed, we'll put that as a 0 as well. And then what do we need to do? We need to know how many times the button has been counted, how many times the button has been pressed, and so that's going to be stored in butt count. And the program has just started, so the butt count will start at 0. Hopefully that makes sense. And then remember, we need to divide that butt count by 4 or mod it by 4, and then we're going to end up with, from that, what the butt remainder, butt REM, and that's going to be equal to 0, like that. I think that's what we need for the button. But now that we've added this wonderful new sensor, we're going to need some new variables. We're going to be wanting to float. We're going to want to float the temp F, so we're going to keep track of the temperature in Fahrenheit. I think some of these things actually measure it in C, so I better get a temp C and I'll convert it to temp F. Okay, I'll get the temp C, I get the temp F and convert it to temp C. Okay, then I will do a float humidity, and I'll just set that to 50 just to give it an initial value, but we'll be measuring the hum or the humidity value. And then I also, the DHT11, it's not very happy if you just sit and hammer it and keep making the measurements very quickly. So we need to put a delay between our humidity measurements. And so I'm going to say the H read time, like when did I read it? Well, the program just started, so I'll say it's 0, and then we'll keep track of that down in the program. But then we also need to know the update interval, and I'm going to the H read time. H read time would then be H read interval, and the sensor is happiest if you're measuring it about every 2 seconds, so we will set this to 2000 milliseconds. Okay, I think we've got the button pretty much taken care of. We have the DHT11, a lot of those variables taken care of. And then what are we going to do next? We are going to have a besides every 2 seconds measuring humidity, every 600,000 milliseconds. So it's every 2 seconds we measure the humidity, and then every 10 minutes we're going to update all those graphs, and 10 minutes turns out to be 600,000 milliseconds. So we're going to do that. Okay, and then we're going to have our raw X data and our normalized X data, and that's just the the x-axis that we are plotting. And we just said we're going to go from pixel 0 to pixel 127. So that x-axis data is just going to be all the numbers between 0 and 127. Now, for all of our graphs, the barometric pressure, the temperature, and the humidity, we're going to use the same x-axis. So I don't have to make a bunch of new x data variables. All of the different things we're doing are going to share the x value. What is going to be different? The y values. Okay, now last time I just had one type of data. The one type of data that I had last time was what? The one type of data that I had last time was pressure. So I just called it raw Y data and normalized Y data. But now I'm going to have other ones, so I need to say, well, that's raw data for pressure, okay? And then this is normalized data for pressure. And then what am I going to need? I'm going to need those same two things for what? I'm going to need those same two things for humidity. Okay, and then what am I going to need? I'm not going to need that. What I'm going to need is now, I'm going to need those same things for temperature. Okay, does that make sense? Now I've got 6 sets of Y data. The raw data and the normalized data for pressure, humidity, and temperature. So that's six y-axis data arrays all together. Now, if you remember before, I said that I had the minimum x value, which is 0, and the maximum x value, which is 127. That's still the same. We're still using the same x. We're still using the same x values. But remember, last time, what did we have? We just had the minimum y value in the minimum y value in the data and the maximum y value in the data. But now we have to have the minimum and maximum value of the data for pressure, for temperature, and for humidity. So I can't just leave this as y min. I've got to make it y min p and y max p. And then what are we going to do? You guessed it. We're going to need that for each one of the arrays. Okay, so then the x stays the x, but then y min p, y max p, y min h, y max h, and then y min t and y max t. Okay, so I'm taking something that was for one graph, and then I'm going to make it where I'm going to have 3 different graphs. So I got to do the parameters that way. Now, if you remember this next stuff, this is just saying where on the OLED do you want your graph to occur? Well, I want the top pixel. I want the graph to start at the top of the graph to be at pixel 14 and the bottom of the graph to be at pixel 63. I want the left of the graph to be at pixel 0 and the right of the graph to be at pixel 127. Does that make sense? Okay, that doesn't change for the different data sets because as I go between the screens, the graph is always going to be in the same place. So these values are going to be shared between the different graphing locations. Now we still have 128 points. That is good. Okay, that is good. Now we've got the barometric pressure that we set up. Now what I should say is very important. For this to work properly, you have to put your altitude in meters, So where I am is I am at 1,127 meters above sea level. For your location, you have to put your altitude in here, your elevation. And then if you take your little pressure sensor somewhere else, you have to update this because this does depend on your altitude. Okay, now this is just setting up the screen. That is good. That's all good stuff. Okay, and then we're now down in our void setup. Well, what did we add? We added that button, right? So we're going to have to do a pin mode for that button. So we're going to have the but pin. And remember, it is going to be an input, and it is going to activate the internal pull-up resistors, okay? Because if you remember back at my diagram of my button, I did not have any pull-up resistors in there. Okay, does that make sense? All right, now what we are going to probably need to do, I'm trying to think. You see, really what we're doing is we're just taking a working program and we are expanding it. And speaking of a working program, I think probably what I should do is just go ahead and run this code. And I'm going to run this code and just see if things are okay at this point, okay? Because we don't want to get well into this and have a million different errors. And so let's just see if we have any obvious typographical errors that we should deal with, like DHT11. What was that? I thought I installed that. Let's come back up here. Okay, so include DHT11.h, all uppercase, include DHT11.h. I thought I just showed you that, and I thought that we had done that. Did I misspell include? No, I did not. And then I have DHT11 sensor library. It shows it is installed. This is particularly confusing. Well, let me remove it. Okay. Okay, and let me install it again. And I always install with all dependencies. Okay, so let's make sure we get our dependencies in there. Okay, so it shows it there. Include DHT11H. No, my mistake. Include DHT.H. Okay, so the library was there. It's just the include, it's just the library name. Okay, that's why we run these things, but that one was scaring me. I thought, how can I not load a library that says it's installed? Okay, and now DHT type, oh, I have a typo there, DHT type. So I had a typo. It seems to slow us down, but believe me, it will go quicker. Okay, now why did I get that error? Because, right, I redefined my variables to not just be raw data, right? So this would be raw data P, and then this would be raw data YP. Okay, so we're going to get more of those types of errors, but we'll just clean that stuff up as we go through the program. The stuff that we did up at the top is working. Okay, now what I want to do is down here, there's a couple of things I want to do. I need to, down here at the bottom, where I have void plot graph, okay, where I have void plot graph, I need to change that. Okay, and what that is that is going to be, instead of plot graph, I need to be more specific. This is going to be plotting the pressure, because the graphs are going to be different depending on what I am plotting. So this one is going to be, instead of plot graph, it is going to be specifically plotting pressure. All right. Now, what else is going to change? The PLPT, PLPB, those things didn't change, but what did change? The Y min became the Y min pressure, right? And the Y max became the Y max pressure, and the Y max became the Y max pressure. So I've got to update these. And then PL, PR, mid, those are all okay. But norm X data, we didn't change norm X data, but norm Y data is the pressure data. And then norm Y data over here, let me get out of your way. See, there's another norm Y data over here that needs to be P. But you don't change the X, right? Everybody shares that same X value. So I think all that's good. Now, what do we have to do? We've got to take this now, copy it, come down here, and we are not just plotting the pressure. What are we also going to plot? So I pasted it. We are going to plot the temperature. And now all of these are still okay, but now instead of Y min P, we have Y min T. Instead of Y max P, we have Y max T. Instead of Y max P, we have Y max T. Okay? And then down here, the X data is okay. The P becomes T. And over here, the P becomes T. And everything else is okay. Now, we have plotted pressure. We have plotted temperature. Who has been left out? The humidity. So we're going to plot here. We are going to plot humidity, HUM. And then same thing, the P becomes an H, the P becomes an H, the P becomes an H, and those are okay. Then the P becomes the H, and the P becomes the H. You see, when you guys are mindful of how you name your variables, do you see how it's really easy to do the type of thing that I'm doing? Okay, now, so we've got plot pressure, we got plot humidity, and we got plot temp. All right, now what else do we need to do? What did we just do here? Okay, now this one up here, this float norm pressure, so this is normalizing the pressure, but all of this is doing is just some reading, so we don't have to do that. But here, where it says normalized data, we're going to have to normalize the data for the what? For the P, for the pressure. And then similarly here, we're going to need Y min P, Y max P, raw data, raw Y data P, Y max P, Y max P, and then X min doesn't change. Raw data X doesn't change. X min doesn't change. X max doesn't change. Nothing changes here. But remember now, this normalized Y data becomes 4P. So we've got a P, a P, a P, and a P that we added there. Then that it normalizes the pressure data. Okay, now what else are we going to have to do? We're going to take that, come down here, outside that last curly there, and now what are we going to do? We're going to need to do the same thing only for T. Okay, and then T. And make sure that you don't miss one, because believe me, it's going to be a mess if you miss one of those. So I've got normalized Y data. What? T is Y min T, Y max T, raw Y data T, and Y max T. That all looks good. And now who has been left out? We have left out humidity. So the P becomes H for humidity, and then H, and then an H, and then an H, and then an H. I bet you didn't think when you got up this morning you would watch me pasting H's for 30 minutes, but this is the quickest way to do it. I was thinking, should I just write the whole program from scratch? But no, you know, we're up to like almost 200 lines of code before this is over. So I really wanted to take advantage of the things that we had done before. Okay, so we've got that stuff done. Okay, we've got that stuff done. That looks pretty good. What do we need to do now? We need to come back up to the top of the void loop now. I prefer to be a little bit larger. I think it's more personal. What's really impersonal, now that is really impersonal. I like to be about this size. You can see the code most of the time, and I'm able to kind of talk to you a little bit more personally. Okay, so let's see here. I'm just glancing over my notes. Okay, so let's go to the void loop. I'm finding my void loop. You can find your void loop. Let's see if I needed to do anything in the void setup. So what did I do? I took care of my button with my pin mode there. That's good. And then did I need to do anything else in there? I don't think I really needed to do anything else except down here I need to. So this is the end of my void setup, and I need to make sure that I dht.begin like that. So I turn on my sensor, and remember, this sensor doesn't like to be bugged a lot. So I'm going to put, after I tell it to begin, I'm going to put a delay of 2000 just to give it a time to settle in before you go in and start making measurements. Okay, now we're going to come down to our void loop. So what are we going to do? Every time through the loop, we got to think of our program flow. Every time through the loop, I want to make all the measurements. So I want to measure everything, whether I'm on the barometric pressure screen or the overview screen or the temperature screen. Every time I want to take all the data, okay? And then the branching is going to occur down here where I decide what I want to show. Okay, the branching occurs down in the bottom of what I'm going to show, but I'm going to be taking data every time through the loop. And then every 10 minutes, I'm going to be updating all of my data arrays and updating the graph every 10 minutes. And then the branching on the button is just what graph I'm going to show. But everything else I do every time. Okay, so what am I going to need to do up here? Well, I'm going to measure the barometric pressure now. That's just a barometric pressure measurement. Then, as before, we are doing a low-pass filter. Okay, we're doing a low-pass filter. And then, now what I want to do is, now what this is doing is this is deciding whether you want to update your graphs. Well, wait a minute. Before we do that, we need to make our other measurements. Okay, so what I'm going to do is I'm going to measure temp C. Now, I could measure that from the DHT11. I could measure that from the DHT11, but you can measure it from the barometric pressure, the BMP 180 chip, and I think that is maybe a little bit better measurement. So I'm going to do that. I'm going to measure temp C by BP.read temperature like that. So now what do I have? I have my temp C, and if you remember, I've got my temp C, but if you remember, we set that variable up at the top. Now, we got to remember what I could do is I could do something as simple as humidity is equal to DHT.read humidity, read humidity like that, right? I could do something that simple, but now it would be reading it every time through the loop, and for humidity, that is too often. So I need to do what? If millis, that is my present time, if millis minus H humidity read interval, humidity read time, okay, that's the last time I read it, the humidity read time. If my present time minus the last time I read it, if that is greater than the H read interval, so my elapsed time is greater than my read interval, then I want to make the measurement. So if millis minus h read time is greater than h read interval, then that is when, get rid of that close, that's when I want to do that step. Now I'm putting my close to the if statement in. Okay? I'm going to do a Control T to try to clean this stuff up a little bit. Okay, that looks good. Now, what else do I need to do in here? Well, I need to do an H read time is equal to millis. So what that means is if I get in here and I make a measurement, I need to update the read time to the present time. So that makes sense. Also, I did temp C. This would be a great place to go in and say temp F, and that is going to be equal to temp C. And this is kind of a famous equation, temp C times 9 divided by 5 plus 32. Probably 7th grade physics you ran into this, and you were probably not so happy having to memorize this, wondering why anybody would need to be doing these conversions. But the day has occurred, the day has come now where you need to do the conversion. So that's all good. All right, now what is this? So this is the end of my make a measurement every 2 seconds, right? This is the end of make a measurement every 2 seconds. And now what is this if? This if is I'm sitting there measuring live data. I'm sitting there measuring live data, right? But now every 10 minutes, remember update interval was set to 10 minutes. Every 10 minutes, I want to update those arrays that I am graphing. Okay, I want to update those arrays that I am graphing every 10 minutes. So how do I do that? Well, I go through, I start at I equals 0, and then I go I is less than num points minus 1, because what I'm doing is I'm taking all the data and I'm shifting it to the left one. So I take the data point at the I plus 1 and I move it to the I position. But since each time through the loop I'm looking forward by 1, I can't go to num points because I would be out of range. I've got to stop 1 before the end, and then I get the end endpoint and bring it in. And if you look at this, hopefully this will make sense. But what you got to see is I can't just do raw data, raw Y data, right? We had to make it raw data, raw Y data P. And then similarly, in the same for loop, we want to update all of our data arrays. So I'm going to paste that 2 more times. But this one's going to be raw T, and that's T. And then this is going to be H, and this is going to be H. So I've updated all of those arrays. Okay. Now, last update was at millis. That's good. But now I have raw data, raw Y data. You got to make sure that it is raw Y data P is equal to barometric pressure. Then what we can also see is we can see, so what this is doing is this is taking the latest reading and putting it in the array, right? We took the array and we scooted it to the left one, and now we're taking the active last reading and putting it in that last position in the array. And so we're also going to need to do that with what? T, okay, of num points minus 1, and this is going to be equal to temp F. All right, and then raw Y data H is going to be equal to num points minus 1, and then that is going to be equal to our humidity reading. Now let me go in and make sure that I looked at my data when I set those. Did I set values up here on the, yeah, I can't remember if I really explained these things when I put them in up here, but kind of like the minimum pressure the minimum barometric pressure you're ever going to run into is 28, and the maximum is going to be 31. But now this is where, and I didn't update these, I just pasted them. What is the minimum humidity value that you would likely ever run into? We've got to set that. Okay, the minimum humidity value that you would ever likely run into would be something like 30% humidity. That would be like a very, very dry. And what would be the maximum humidity that you would ever run into? Well, likely 90% humidity would be the biggest thing that you would ever run into. Now, you need to set your minimum temperature here. And if you decide to use centigrade, you need to use different numbers. And depending on where you live, you need to use different numbers. But I'm working in Fahrenheit. And working in Fahrenheit, the minimum temperature I'm ever going to run into is about 60 degrees Fahrenheit. And the maximum I'm ever going to run into is 90. So when I did all this fast and loose copying and pasting up here, I forgot to update those values. All right. And let me make sure everything else is good. Okay. Yeah, those things look good. Okay. And as I started setting these things up, that reminded me that we needed to do that. So come back down to your void loop. Let's get back down into your void loop. Okay, we're down in our void loop and we're setting things up, right? So we did the raw data, we updated our raw data, and then after we update our raw data, I'm just thinking where the best place to do this is. Okay, I think that what we're going to do is we're going to do the normalization down under the button push. Okay, so when we're doing a button push, that's when we're gonna normalize the data. So give me just a second here. So this normalize the data and getting ready to plot, that we are not going to do here, because we don't want to do it every time. We want to do it now based on what button has been pushed. So we don't want to do it as part of that loop. So those 3 lines of code you take out, and just setting the humidity is the last thing. Now this is the end. That is the end of the if statement that's going to update those arrays every time, every time that we're ending up every 10 minutes. Okay, so now that was the every 10-minute part. Now we're back to the every time part. What do we want to do every time now? We got to figure out what we're going to put on the screen. And so what do we need to do? We need to read the button. So I'm going to say but val is equal to digital read but pin. So now I've got a value. Now what do I do with it? Well, if but val equals 0 and but val old equal 1, that means the last time through the loop the button was down, okay, and this time through the loop the button is up. Okay, so I just read a 0. Last time I read a 1. That means the button was pressed and released. So in that case, what do we want to do? Well, we want to increment the but count because it's been pressed again. The but, man, I can't get a capital C. But count equal but count plus 1, like that. Now, what do? We take that but count and we mod it. We mod it by 4, right? We mod it by 4. And what will that give me? That will give me the but remainder, right? So now I'm going to, as I press the button, that but rem is going to go 0, 1, 2, 3, 0, 1, 2, 3. It's going to cycle through the different parts of the screen. So now what I'm going to do is I'm going to look at but remainder, and then I am going to decide what I am going to do. Okay, well, let's look at this. But let's say now I want to see what is the remainder. Well, if but remainder equals 0, okay, that means that, you know, there hasn't been a button push, or we've gone 4 and come back to the starting place. What do I want to do? Well, I want to do everything that I did last time. But you see, no, I don't. No, I don't. You know what I want this to be? Okay, what I'm going to do is this code we're going to just kind of keep down here. That code we're going to keep. Okay, but now what am I going to do here? Let me make sure. I always like to put my closes in. So that closes the if statement. What do I do in this particular case? Nothing's been said. Well, I want to clear the display. And what do I want to do? I want to put those 3 live numbers up, the 3 live numbers. So this is going to be our overview screen. So then I'll put the set cursor at 0, 0. Right? You should be familiar with this stuff. I need to do my OLED.set text color, and we'll set that to white, like that. Okay, then I'm going to do my OLED.set text size. I think we were using 3 last week, but 3 doesn't fit very well, so I'm going to do a 2. Okay, and then I'm going to say OLED.print, where I'm going to print temp F, and then I'm going to do an OLED.print, and what am I going to print? I'm going to put a space and F. So on the top of the screen is going to be the temperature in Fahrenheit, the live temperature, then OLED.print, and then what am I going to print? I'm going to print the humidity. All right, but this one I want to go to the next line. So after I print the F, then I want to do a print ln. Right, now this is going to be the humidity, and then I will put the label OLED.println, and that is going to be, in quotes, percent humidity, like that. Okay, now we're going to go to the third line, OLED.print, and then what do I want to print? The bar press. And let's make sure bar press is the one that's been filtered. So we come up here, yes, bar press went through the low pass filter. So that's the one we want to use. Okay. Barometric pressure. Then we're going to do an OLED.print, and then this is going to be our label for that one, and that is going to be a space IN and then HG, inches of mercury. HG is the periodic table designator for mercury. Okay, now we've got all those things. What do we need to do now in OLED.display, like that? Okay, now this is probably going to be one of the hardest parts of the program because we have done a whole lot of coding, and now we're going to run it and see if we get something on the screen. Okay, we're going to run it and we're going to see if we get something on the screen, but this could be like some very tedious debugging here because I have done a whole lot of coding since we did that. So what I'm going to do is I'm going to turn this off. Okay, now what I will do is I've got the USB now plugged in, and now I'm going to run this, and let's see what we get. Getting an error is actually easier than not getting an error and having it not do what you want. Raw data, raw Y data, what was that? Raw Y data. Okay, do you see that? I did those wrong. Raw Y data, like that. Do you see that? Okay, but what I was saying is that if you get an error, it's pretty easy to go in and find it. But when the program compiles and downloads and then doesn't do what you want, then that is a harder case. Did I do that again? Raw Y data, or raw Y data. Okay, now let's see. Okay, that's looking good. Okay. Butt val, what is that? Butt val, not declared in this scope. What is that? Okay. Butt val is equal to digital read. I thought I set up that butt val. Let's come up here. That was almost all the way to the top, wasn't it? Butt val, uppercase A, little l. Okay. All right. Yeah, what's really hard is when the program runs and downloads and doesn't do what you want. Then that can be some harder things. Okay. Yes, OLED display little d. See that? OLED display little d. Bar press was not declared. Uppercase B, I think. You see, that's why I needed to be more consistent, like always start with the lowercase letter, but this bar press I did different, right? The bar press, wherever it was up here, I did that one different. Let me make sure. Yeah, bar press. You see, I did that one a little different, and that threw us off. Man, I wish I had an assistant that would go get me another cup of coffee. I think this is a 2-cup lesson that we're doing here. Norm data is not declared in this scope. Okay, so this is down here. This is okay. So what this is this, I think, is now the part that would be the barometric pressure. Like this is now part of the void loop that we do every time. Okay, because this closes the if statement for but remainder is 0. So now what we need to do is this was the part that plotted the barometric pressure. All right, so I need to say if but remainder equal 1. That means it's been pressed one time. Then I want to do all of this stuff, which is all associated with, I want to do all of this stuff, which is all associated with the barometric pressure. Okay, now I need to, after the delay, I need to close that if statement, and then I think I'm going to take that delay out. All right. Now, this is what I want to do when the press button is pressed the first time. I want to go in and I want to show the barometric pressure. Now, what else do I need to do here? Now, I'm not just going to do a norm X. I'm not just going to do a norm data, right? I'm going to do a norm data P. And I'm not going to plot graph. I'm going to plot press. Remember, we made those adjustments. Okay? When we generalize the program, I think there's a better chance that this is going to run this time. Going, 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 going. Man, these things take a long time to compile as we're loading a lot of libraries and doing a lot of stuff. Okay, look at that. All right, and all eyes over here. Well, what I need to do now is I need to unplug, and then I need to turn this on, and then all eyes on the OLED. And this is the thing that we fear most of all, where it just doesn't do anything at all. Let's see if I can do it again. Why? Boom, look at that. Okay, look at that. So our first page is working, sort of. Looks like I'm getting kind of a... Okay, so I need to, up at the top, somewhere I need to clear the display. So on the first page, okay, this, at the top of the first page, instead of displaying the data, I need to clear the buffer. So I'll make that a clear display. You see how kind of like as it changes, it's writing over itself. That needed to be a clear display. And then down here, yeah, this one was right. This one was a clear display here. So that looks good. Okay, the one other thing I realized is we're debugging this, where I say to update the graphs every 10 minutes. In debugging, we need to set that to like 600, so it'll be updating it, and we can see if those graphs are working. We might actually get the first graph working on this one, and so let me make sure that I turn this off and I get this plugged back in. Okay, I'm just saying don't have the USB and the power module on at the same time, because then you're putting like two different voltage sources, and that can sometimes cause problems. Okay, so that's there. Plug that back in, turn this on, and then it seems like when we do it that way, we got to come in and reset it with the little button on the Arduino, and boom. Okay, now let's come over to a more full view here, and you can see I have 86.54 degrees Fahrenheit, 55.6% humidity. You see I need a space before the H, and then 30.07 in HG. So let's come here, and on our label, let's put a space in there right here, right? Put a space there. Right. We won't rerun it right now because that was a simple enough fix. Now, the big question is our program flow working? Will this take me to the barometric pressure? And it did not. So our button press is not causing any action to happen. The button press is not creating any action. So I've got but REM is equal to but count mod 4. All right. And if but remainder is 0, then I should do this, which it did. But then if but remainder is equal to 1. I know what I forgot to do. Up here, what do we have to do? We got to tell it that but val. Oh, you didn't see that. I caught it pretty quick though. Okay, so this is where the problem is. I was looking at the code. Hopefully you were looking at your code. But remember, we've got but val and but val old, and we've just done the but val stuff. What did we not do? But val old now is equal to but val. That's what I was saying. It's hard when it runs and you don't get an error. Then it's harder to find your mistakes. But now we will need to download this. We'll come over to the bigger view here, and let me plug the thing in, and then again, I'm just plugging and unplugging the USB as I'm turning the power module on and off. Okay, so we can unplug it, and then we can come over here and we can turn it on. And then the other thing, the reason that we might not be seeing it, remember there's like a 2-second delay. There's like a 2-second delay. And so I'm going to press the Arduino reset button again. But we had it wait 2 seconds to let the thing warm up. Okay, so we have 86.36 F. That looks good. 50 degrees humidity. That looks good. We've got a, we've got a good percent humidity there. And then 30.07 inches of AG. That looks good. Now, the only thing that scares me, good. Okay, 50.1. That kind of scared me because remember how we set the initial value to 50% and then it was showing 50%. And I thought, did we remember to measure humidity? But yeah, when I saw it go to 50.1, I know we were. Now, this is going to be the clincher. What happens if I press this? Boom. I go to the inches of HG page. It's showing me instantaneously right now and updating. This number is updating every time through the list, 30.07 inches of HG. And now it is building the graph. It's building the graph really quickly for debugging purposes because we set the update interval to 600 milliseconds. Well, what's the problem with this? You only get like the last 10 seconds of data or the last few minutes of data, and you're going to want more data than that, but that helps us get the debugging done. Now, this I think will go nowhere because we didn't do for the case RIM 2, and we didn't do for the case but RIM 3, but now this should go back to but RIM 0, and it does. Okay. Guys, we are really, really well on our way. This next part should go fairly quickly, I think, because what we're going to do now is for this but rim equal 1, we're going to take all of that down to that first close curly, because that closes this curly, and we're going to copy that, okay? And this closes the void loop. This one closes the void loop. So we want to stay in the void loop, but I'm going to paste that. But this is going to be the remainder 2 case. And there, instead of barometric pressure, we are going to do, what are we going to do? Instead of barometric pressure, we are going to do, let's do temperature. Okay, so I'm going to put temp F, okay, temperature in Fahrenheit, and then this will be, I'll just put an F for the label, and very, very important, I want to normalize it, not normalize P, but normalize T. So you see, when you do this fancy cutting and pasting, you got to make sure that you're updating everything. So now for RIM 2, but RIM 2, we are doing temperature. And so now we go, right, we're still inside the void loop here. We want to go before the end of the void loop. Come right here, we want to paste again. And then what we're going to do is we are going to come in, and that was but RIM 2. So this is going to be but RIM 3. And then what is this going to be? This is going to be humidity. And this is going to be a label of, what did we label that? Help me remember what we labeled that is. We labeled it a space and percent humidity, like that. Okay, so now I'm going to turn this off. I'm going to plug the Arduino in, and then we're going to try to run this. We're going to try to run this. It is downloading. Okay, why don't we come back to our bigger, fuller view. And now I'm going to unplug the Arduino, and then I am going to turn the power module on. And then what we also see is that for some reason I need to press the reset button on the Arduino, and then we're going to have 2 seconds to fire up the humidity sensor, and boom, 86.54 degrees F. We have 56.7% humidity, And then we've got 50.2. That jumps around a little bit there, doesn't it? And then I've got 30.06 inches of HG. Now, if I press here, I am building my barometric pressure chart, and it's charting good. Remember this horizontal line here that goes all the way across, that's the standard barometric pressure, which is 29.92 inches of mercury. And so 30.06 is a little bit more than that, again, indicating that we've got a relatively high pressure. And like I said at the start of today's lesson, it's kind of been going up. So we're expecting clear weather. And if we take a look outside, indeed, we are getting clear weather. So that looks good. Now, will we go to Fahrenheit if I move here? Look at that, 86.9 degrees Fahrenheit with a graph building. And then I've got 50.3% humidity with a graph building. And then 86.9, 50.6. Look at that. Boom. Okay. Now, what you're going to want to do is you're going to want to go back. You're going to want to go back over here, and you're going to want to set this back to 600,000. Okay, you're going to want to go back and set that back to 600,000. Okay, and then you're going to want to turn it off and download it. But what I want to show you, is that look at this now. I am going to get this, and then I am completely mobile. Okay, I am completely mobile. You see, I can put this wherever. I can walk around with it. And then you see, you can make your readings. That's not going to want to focus, is it? Okay, it's wanting to focus on my face. But anyway, so you see, you've got this now, and boom, 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 boom. Okay, so that is just a pretty slick, little device, if you ask me. I think that this has been a project that has been well worth the time that we have invested in it. What are things I like? I like that it is portable. Okay, I like that you get the user interface from the button, not from the serial monitor. I like that we're using a lot of different sensors. What's the one thing I don't like? The Arduino form factor here for the Uno R4 Wi-Fi, it's all of these wires, to where if you think of something like the old Arduino Nano that just plugged into the board, for Arduino to really have a clear path forward, they're going to need to take this Wi-Fi board and they're going to need to make it in a form factor that would plug into a breadboard. Because you see, look at this part of the circuit, how neat it is with those little jumper wires. You see how I have those beautiful little jumper wires and everything is so nice. And then you get over here, and this is big, ugly, loopy wire. So really, I think if Arduino is going to have a viable future and compete with something like the Raspberry Pi Pico W, they're going to need to make this in the old Nano form factor, or something that looks like the Pico W that you can just plug in. Okay, but that is pretty neat. Now, the other thing I'll say is I'm not going to give you a homework assignment for next week. Your homework assignment for next week is I'll give you a little time. Just go in and catch up with where we are here on this. Catch up with where we are here. If yours isn't working already, like mine is, go ahead and get it working. But what are we going to do now? We've spent 6 weeks working with this GY87 module. And after those 6 weeks, those 6 lessons, we have used one sensor on this module. There are 10 sensors on that module. And so what we're going to do next week is we're going to probably crack open another one of those modules. We're going to crack open another one of those sensors on this module and start playing with it. But for now, go ahead and leave your button and leave your display and leave your GY87 and leave your power module on there. Now, I'm not going to be using the humidity sensor in the future, so we're going to take that off. it's going to be painful for you, right? Because you like your weather station. You might have to go out and buy another kit so that you can start leaving some of these projects hooked up. But what we're going to do is we're going to go in and we're going to start working with one of those other sensors next week. Okay, guys, I really hope that you're enjoying these lessons. And the thing is, again, what most people do on their classes is they have one lesson that does everything, but what they do is they've already written the code and then they just kind of discuss it a little bit with you, and then you run out and you copy and paste their code, and then you look at the schematic and hook the circuit up, and then everything works, and you feel like that you're a programmer, you feel like you're an engineer, but you would never be able to go and do that on your own because you're copying and pasting. You're going with me through it step by step, and I'm giving you homework so that you have to think about it before you see me do it. And then also you're typing and you're thinking, and then you're having to debug your code, and you're watching me debug my code, and you just don't get that part of the brain developed if you're just copying and pasting. Now, what's the good thing about that? By taking these classes, you're actually learning something. What's the bad thing about that? Instead of getting hundreds of thousands of viewers, I get thousands of viewers, because there's hundreds of thousands of people that want to copy and paste, and there's a few thousand people that actually want to learn how to do it. So I am making the deliberate decision to teach at the expense of the number of views that I'm going to get. Okay, so hopefully that makes sense. But with that, what it makes me always need to remember to do is to thank you guys and give you guys a shout out who are standing with me on Patreon, because it is the Patreon support that allows me to make these videos that actually teach but don't get hundreds of thousands or millions of views. So thank you guys for allowing me to teach. Also, you can help this channel if you'll go ahead and give this video a thumbs up and leave a comment down below, because that helps us with the old YouTube juice. If you haven't already, subscribe to the channel. When you do, make sure you ring that bell so that you get notifications when future lessons drop. And most importantly, share. Boat. Just pause and take it in. Pause and take it in. Okay. And most importantly, share this video with other people, because the world needs more people thinking like an engineer and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.